Hello, I'm Chris Pitt and welcome to the 7th SYNTH development blog. In the past couple of weeks I've been concentrating on hardware development and I'd like to share with you the progress I've made. Firstly, as you remember, we were having problems with the contact drum pads. When I hit this one, the physical sound will be carried down these rather solid neoprene support pillars, back up these and into an adjacent pad, and I had to write a piece of software to try and counter this problem. But I've decided also to replace this rather hard neoprene that's supporting these pads with this rather squishy foam, hoping that there will be less physical transmission of the sound round. Okay, moving on, I've been looking at the ultrasonic string. I know I've got a good amplifier to amplify the signal coming out of the sensor, but I've been developing a circuit to drive the transmitter. And here it is, a test circuit on a piece of Vera board. I'll just turn it over. As you can see, it's two BC547s basically, and four resistors, and I've got the scope probes on either end of the transmitter here, and if we look at the scope on the PC, we'll see we're getting good clean waveforms out of the driver circuits. I'm running these from the Explorer board. It's just a little bit of code I knocked up to generate out antiphase 40 kHz pulses, and I've got 8 pulses there. Okay, so now I've connected one of the scope probes to a receiver, just straight across the receiver, no amplifier or anything, just to see if we can get a signal back. So I'm going to wave my hand like this over there, and if we look at the screen, yeah, we can see we're getting a nice signal back reflected off my hand, and we can detect the distance of my hand away by the distance of the return signal from the drive signal. So all is good with the ultra string. Okay, so moving on to the radar bow. This detects the speed of movement in front of it. It uses a little Doppler radar module running at 10 GHz, the sort that are used for opening doors in shops and offices. As you can see, this is the back with the can over the radar bit, and there's the front, and these little rectangular things in the corners are the patch antenna for the radar. This needs a preamplifier to make a usable signal, so as you can see, this is a much modified contact radar board that I pressed into service for that purpose. Okay, so here it is running, and what I'm doing is simply moving my hand up and down in front of it, and if we look at the output on the oscilloscope, if I move my hand slowly we get a low frequency, and if I move it quickly we get high frequency output. When I say high frequency, this is on 100 milliseconds of division, so the highest frequency is only a few tens to 100 or so hertz. And that's it. All I need to do is feed that into the A to D of the pick and measure the frequency, and I can measure the speed my hand is moving in front of it. And lastly, we have the finger string, and this is basically measuring the resistance down a stainless steel wire. So here we have a stainless steel wire, which are rather hard to see. This was bought cheaply off eBay and is actually intended to repair electronic cigarette heating elements with. This is kept taut by two guitar machine heads, both bought as a set cheaply off eBay. The ends are just two bits of copper rod, and we make contact with the string onto some copper tape. I'm not convinced by the copper tape, and I have got some copper strip which I may replace it with. Okay, this goes into a differential amplifier, so it amplifies the voltage between the end of the string and where you make contact with the copper tape using your finger by pressing down. The string is connected between these two presets, which are 25 ohm, just so I could play with the values. So a current passes down the wire, so there's a voltage of a few hundred millivolts across the ends, and we're interested in the voltage here, which depends on where you press with your finger. Okay, this differential amplifier is producing two outputs. One is the voltage between the bottom of the string and your contact, and the other one is the voltage up the whole length of the string. I'm not sure this is very useful, but I'm going to include it so I can have a play around and see if there is any use for it. Okay, so the outputs of these two amplifiers just go into the picoscope, and this is displayed on the screen. So the blue trace is the string and the red trace is the voltage across the whole string. The blue trace is the voltage where you press down with your finger, and the red trace is the voltage over the whole string. So we can see if I move my finger up and down, we get between 0 volts and 2 volts. Where I think measuring the voltage across the whole string might be useful is if you do that. I'll show you what I'm doing. You get this dip. You're effectively shortening the string and get this dip in the voltage across the whole string. I might find use for that and I might not. And finally, the design of the electronics is well underway. What I've decided we're going to do is we're going to have two boards for each input type. Here we've got a contact drum. As you can see, I've just printed out the board layout on thin card. The way it will work is the electronics that are specific to the particular input type, here the amplifiers for the contact drum sensors, are on the top board, which plugs directly on top of, and I'll take this off now, a standard microprocessor board which contains the PIC micro, the 48 Max, the RS485 chip and the power supply. And there'll be one of these for each type of input. More of the hardware development next time. Well, that's about it for this development blog. I look forward to seeing you next time. Goodbye.